Okay, let's kick it off. So my name is Karl. I'm really glad to be part of the hackathon and represent Galadriel. I am the head of growth at Galadriel. I really love working with developers, mostly because originally I am a developer myself, and I have now more transitioned into helping the army of developers to kind of onboard into building with on-chain AI. And I have prepared a few slides and a workshop for you today. And as was already mentioned, the workshop is about building on-chain AI agents. And before we start, if anything, my goal for you today would be, or my goal today would be to inspire you to experiment and build with decentralized AI, build AI apps and agents on chain, because we see this as the next frontier in tech. And I'm here to kind of show you how this can be done using Galadriel. Yeah, so without further ado, Galadriel is the first layer one for AI. And what this means essentially is that we enable, or Galadriel enables the developers to build any arbitrary AI application and agent in a decentralized manner and deploy them on chain using smart contracts. So basically Solidity. Just like Ethereum basically has enabled building any general purpose decentralized applications. And here is like a really good visual representation of what this actually means. So you can see a Solidity contract that essentially is an on-chain ChatGPT application. So you wouldn't need anything else but just this Solidity code to run an on-chain ChatGPT. And I'm here to actually show you how you could build one as well. All this is possible thanks to Galadriel's DML, which is kind of our flagship product. And it enables getting the developers to get like state-of-the-art open source and closed source model inference, AI model inference on chain. And all of this in a low latency and low cost manner, which is also like verifiable on chain. And how, let me quickly show you the playground as well, which you can all go and use before you start actually building. You can quickly get like image generation or text generation, all happening on chain, generate the results here. But I think what I want to highlight is how it actually works and show you that like the graph quickly. So when I show you the ChatGPT contract, then you can think this as like this part here. And all of this that I'm showing you in the dotted line is basically what happens on chain. And all of the actual like AI inference is happening off chain inside the DML, which is something that Galadriel kind of hosts, but it's available for everyone to verify on chain as we post the attestations on chain. And simply put, if you build the on-chain ChatGPT or an on-chain agent, then you need to call out the AI Oracle, which is another contract on Galadriel blockchain, but it has been deployed by us. So you don't need to like go through the hassle of deploying any oracles yourself. We have deployed the oracle for you, and the oracle is the kind of on-chain part that interacts with the off-chain DML, and inside the DML is where the actual kind of AI inference takes place. So you can think of the whole flow from your AI agent on chain or your ChatGPT app on chain, calling out the AI Oracle that we have already deployed, which in turn then calls out the off-chain DML. The DML does the AI inference, whether it's an LLM, a large language model, or any like generative model, DALL-E, or something else that we that you can, use. And if the inference gets back, it's posted on chain to the AI oracle, and then in turn this calls your app. It might be a little bit confusing, but we'll also, get to this and actually write some code as well. So maybe it becomes a little bit clear. But this is publicly available for everyone to go and check it out themselves. Maybe before we start and jump into the code, how like TML sets apart from other solutions such as zero knowledge ML or optimistic ML, OPML, is that TML actually enables getting larger models like GPT-4 on chain, the inference on chain in a verifiable manner, as like ZKML and OPML really like struggle because of the computational kind of requirements that it needs. And now to the workshop. Before I jump in and start doing the coding bit, then I actually want to show what we're going to build. And this is the example that we have already kind of built with the Galadriel team. This is fully open source, and you can see it in our GitHub. You can find the links in our documentation as well. And we're going to essentially do the same thing as here. I'm not sure if you can see my MetaMask if I share my screen, but what is happening right now is that I sent a request to on-chain ChatGPT, and I need to confirm the kind of transaction with my MetaMask. So I will do that, and now we need to wait the response. And you can see that it responded me, and you can also go and check the transaction itself as well. See that the data or like the input that I sent it is stored here, and it gave me the response here. So we're going to build like the smart contract part of it. I'm not going to show you how to build the front end for it, but it's also available on chain. Sorry, it's available in our GitHub, so you can go and use the front end as well. Now, let's jump to the workshop and let's do some coding. And with the workshop, I know the title is how to build, or the title of the workshop is how to build on-chain agents, AI agents. What I wanted to do with this workshop is actually take a little step back and provide you with the groundwork on how to use LLMs, which stands for large language models, on chain. And from there, you can basically take the next steps yourself and easily add the agent features, which I'm gonna describe you after we've done the coding. You can add the agent features to like the simple calling an LLM application yourself. And we can jump right in. I'm using Remix just for convenience reasons, but you can use any kind of developer tooling that you're used to, whether it's Hardhat or something else, Galadriel. You can use all of them with Galadriel, so it's not an issue. And before you start building the on-chain ChatGPT, it would be good for you to set up or make sure that you have set up your wallet. You can use any like EVM compatible wallet. I'm using MetaMask. You can use MetaMask as well, but you need to connect it to Galadriel DevNet. And then you also need to get some DevNet tokens to pay for the gas to deploy the contracts, and also do some transactions on the DevNet. And I'm going to follow the tutorial that we have written in our docs. So to all of you who are watching the recording, you can simply follow along the video and open the docs right beside and go through the tutorial with me essentially. Okay, so let's get started. I already put down like the basics, like the base for the contract, which is the first part here. And now we need to set the Oracle address inside the constructor. which essentially means that when we deploy our contract, we are initializing also the Oracle address that our AI contract or ChatGPT contract is going to call out. And if you remember from the TML kind of graph that I showed you, what we're doing right now is defining this address inside our own contract so that our contract knows to call out this contract on chain. And this is what we need to do inside the constructor when the contract gets initialized and deployed on chain. So there's that. Next, we need to add a few kind of helper functions. And these are basically to edit the Oracle address afterwards. So there might be a case where we deploy a new AI Oracle on chain, and you want to use a newer version of the AI Oracle contract that we deployed. So you need the ability or functionality to later on, set the new address to the Oracle or edit the Oracle address that is defined in your contract. So this is what basically all of this does with the added modifiers. So the only owner modifier makes sure that only you as the owner of the contract are able to edit or set the Oracle address. And the only Oracle modifier we're going to talk a little bit about later, but essentially allows only the AI Oracle that I have referenced already so much that I showed you also in the TML kind of graph, that only this is able to call out functions in your smart contract. And you can always get the latest AI Oracle address here in our docs. We update it every day. Now, speaking of the Oracle, we also need to define the interface inside our smart contract. This gives our smart contract the knowledge, or basically defines how we can interface with the Oracle that is deployed on chain. Inside the Oracle, we have it also publicly or open sourced in our GitHub. You can go and check out all the functions that are inside. But the only one that we need right now is create LLM call, which essentially is to start the large language model inference within our contract and call it out inside the Oracle, which then in turn calls out the TML, which lives off chain. Now that this is defined, we can actually go and get to the core functionality that we need to define inside our smart contract. And the first things that we need are two kind of data structures. So we need to store the messages that we send to the LLM inside our smart contract, and not only store all the messages, but we also want to store every chat that gets created and every chat history that belongs to this chat. And maybe to better visualize this to you, I'm going to show you the on-chain ChatGPT application again, and you can think of this here as one message, hey, that I just wrote. And also, you can see that it has more than one chats going on. So this is chat number 1, this is chat number 2. You can add chat number 3, 4, 5, etc. So we need to define this functionality also in the backend, or how it's in Web3, it's on chain, right? So chat run is what stores all of these chats, chat 1, 2, 3, 4, etc. And message is what defines one message. And inside the message, you can see role and content. And to better visualize this, you can see role is user. It makes sure that I can show in the front end that hey came from a user, and hello, how can I assist you today came from an assistant. So the role here is assistant. Next, we need to create a function to actually start a chat. So for this, we need to implement the start chat function. And in this, you can see the input is the message. So this will be what the user will send to the AI or the LLM. This is what I wrote in the application as you saw as hey. Within the function, we define that the sender is going to be a user. So it's going to be me. And we also combine it with the message itself. And we store it inside the message struct here. So it gets stored on the same smart contract. And in turn, you will get an ID that represents that like chat that is created. So you don't send to the Oracle. Here you can see that we call out the function from the interface that we define above here. So you don't send the actual message or the content itself. You will send the chat ID that, or you will send your Oracle address, and you will send the chat ID that the Oracle then can, retrieve the data from your kind of contract storage from. So let's put this functionality here as well. I must have forgotten to add these data structures in the beginning. So let's add these as well. Okay, looks good. So now we have the functionality to start the chat. Now we also need another function to continue a chat. And how to make it really easy to understand is that you can start as many chats as you want. So you can see from here, you can go like 1, 2, 3, 4, 5, however you want. Anytime you start the chat and send the initial message, then the start chat function is called. If you already have started a chat and you want to continue a chat, then you need to call out add message function. And what this does is essentially tell to the AI Oracle that I give you this chat ID. So it's like, for example, chat number 1. Please add one more message on top of this. And what this enables is the LLM to actually have a chat history as well. So if you go to like ChatGPT or any of these applications that are online, then it's not like you send one message and you get a message, like a response back, and then the application totally forgets about like your conversation history. So this is what we're trying to implement here, is that the application is actually aware of the previous conversation that you had with the LLM. So for this, we need to implement a functionality to add messages on top. And this gives the LLM the ability to actually, have context about the previous conversation that you've had with the AI agent or the chatbot. Start chat, and we need to also add message here. So now we have all the write functions in place, but we also need to have a few read functions for us to actually, if we're building an application, we want to show like what was the response and what's the chat history, etc. Without that, we wouldn't be able to, read what the response actually was. So we need to also define get message history contents and get message history roles. And in a nutshell, what this gives you back is a table like this. So you'll be able to show in the front end that user said hello, and assistant said, hi, how can I help you? The user said this, and like you stack up the whole like chat history like that, basically. And for this, we need to define these two functions. Let's add them here to the bottom. And as you can see, the input is always the chat ID. So to visualize this again, let's say this is chat ID 2, and I call out here, get chat history. Then I see that the user said, hey, the assistant said, hello, how can I assist you today? It's pretty straightforward. Now, if you remember from the TML graph that I showed you, I'm just going to quickly pull it up again. You can see that if you send a request for AI inference from your smart contract, so like start the chat function basically, with the message and the defined model that you want to use, then the AI oracle here gets your message and it forwards it to the off-chain TML, which starts the actual call to the AI or AI inference and pushes back the result to AI oracle contract, not straight to your app contract, but to the AI oracle contract that we have already deployed for you. So you don't need to worry about this at all. But what you need to worry about is defining in your smart contract the callback function that the AI oracle here can use to forward you the message that came from the AI inference. So you can see that the inference callback with the results needs a callback function. And this is why you need the on-oracle LLM response function here. And you can see that it needs as an input the run ID, which is the chat ID essentially, and the response that came with it. Or if there's something that went wrong, it will forward you the error message itself. And you can see here that it says that the message came from an assistant, or it assigns the message to an assistant and then stores it into your smart contract. Let's add this here to the bottom. Okay, so now we have basically all of the code that we need for on-chain ChatGPT to work. Let's try to compile it. Let's see if it works. It did. So what we can do now is actually go and try to deploy it as well. This compiled. Here you can, why I use remixes like for quick experimentation, basically it enables me really easily using MetaMask to connect to Galadriel network. So I have connected to Galadriel network. Now I want to deploy this contract, ChatGPT contract, on the Galadriel layer 1. But as I said in the beginning, we defined in the constructor function that I need to also specify the oracle address. So I need to tell my smart contract here on the left what is the address of the AI oracle contract in order for it to be able to actually, communicate and do the AI inference. And where I can find this is here in the docs. We update the oracle address on a daily basis. You can simply copy paste it and add it here. Now my smart contract knows which oracle to call out for this AI inference. I hit deploy. I'm not sure if you can see MetaMask, but essentially I have to confirm the transaction. I hit confirm. Shortly, it already succeeded, so the smart contract is deployed on chain on Galadriel L1, and now we can also, go and try to use it. As I said, like the first thing that happens, let's go back here for a second. MetaMask, delete all these. The first thing that happens if I type my first message here is I call out the start message function in my smart contract. So I need to first call out, start chat, not start message, start chat. Let's do the same here. Let's type in hey and transact. MetaMask pops up. I need to confirm the transaction. The transaction succeeded. So what this means is that I sent from my smart contract, from here on the left, I sent a message to the AI Oracle. This transaction succeeded. Now AI Oracle forwards that message to the offsite TML and waits for the response and then forwards the response back to me. So let's see. I have to use the chat ID because I started the chat and now I want to read the response that came from the chat. So I need to use get message history. Remember the last two functions that we, the last two functions that we implemented in a smart contract. And if I call out this, this was get roles. I need to call out get history, get chat history. There we go. You can see I typed hey, and the assistant replied with hello, how can I assist you today? Now, if I want to continue the chat using this chat history, so the AI is aware of the context and what we've been talking together with the AI, I need to define the same chat ID here that I used, here, and then add like another message on top. How are you doing? Transact. I need to confirm it with the MetaMask again. The transaction is confirmed. We sent a transaction from my contract to the Oracle contract with this, payload. How we're doing the chat ID. What happens in the background is that the Oracle contract is now communicating with the off-chain TML. It waits for the response to get back to the Oracle, and then using the callback function that we defined here, it is able to communicate with our contract and store the response to our contract. And we can see by using the get message history that the response was thanks for asking, I don't have feelings, yada, yada, yada. So this is the coding part. For the sake of time, I'm not going to go through the rest of the slides, but I will share the link with you. Here are a few tips that show you how you can turn this simple ChatGPT application into an actual on-chain agent. And what makes an agent different from a simple chatbot is essentially two things. Number one is that it is able to run in a loop until the user task is completed. So you don't have to type in the reply every time, but you can simply say your task one time, and it goes in loop until it finishes your task. And second thing is the ability to use tools. So we also support the LLMs to do web search, or use code interpreter, or generate images. You can find out about these things in our talks as well. Here are a few of the examples of the best agents that have been built. You can use these as basically inspiration. And in the end, there's a tutorial that we have in our docs that enables you to, if you go through the simple one here that I just showed you, you can start building your own agents by simply following the tutorial here. Yeah, I think I've already gone past the 30 minutes, but if you have any questions, then, or if you want us to help you, find the best idea for the hackathon, or like just any questions how Galadriel works, or this was a little bit too confusing, then you can simply find us in the Encode Discord server, or you can also join the Galadriel server, which you can find from our like homepage. And yeah, we try to be as accessible as possible. We're kind of try to be always online.
There are questions actually. So if you navigate back to yes, to live stream, there's the question tab on the bottom right side, and you will be able to see at least 3 of them. There's a few more in the chat sections as well. So bottom right, there's a question tab, and you will be able to see the list of the questions that have been posted.
Okay, so I hope I'm pronouncing this correct. Sorry if it's not correct. The question is, does the smart contract store the whole prompt and the completion or hash of the prompt in its states? So it stores the whole prompt, and I'm not sure what you mean by hash. I think I guess the question is the data encrypted or not? And if your question is it encrypted, then the answer is no. With the current version, everything is stored publicly on chain in your smart contract. Also the prompt itself and the chat history and the replies, etc. Now the second question from Kaho again. Is Galadriel compatible with frameworks such as Landgraph, AutoGen? Is the Encode within GPU? So what you're basically asking is where does the orchestration happen, like the prompt building, etc. We really want, or kind of expect the developers to do as much on chain for their own learning and for us to learn, but a lot of the developers that we've seen have been building the prompts off chain in their front end or in the client side, so you can use it whatever framework you want there. And essentially our kind of dream or goal is to build an abstraction layer which is similar to LangChain or the things you mentioned here, but also enables the developers to build orchestration on chain within the smart contract itself. And enclave within GPU. I'm not sure. You can read more about the enclave itself from the TML page here. We are hosting the enclave. I think it's some AWS solution that we have in the backend. I am not that technically capable of explaining all of the details, but if you have any questions regards the enclave, then just hit the dev support channel in our Discord, and our engineers will be able to answer you regards that. And the third question is by Soremba. Can you comment on the convenience of including RAG, which stands for Retrieval Augmented Generation, with Galadriel? I'm not sure what you mean by convenience, but I can maybe explain the use case a little bit, what this enables. So when you think of a simple large language model, it doesn't always have the best knowledge base or context about the given use case that you want to use it for. We can think of an example, for example, You want your personal assistant that has all the information about you. Now, if you just ask ChatGPT, you know, who is Karl, what's Karl's profession, how old is he, the chat or like the large language model has no clue. That it doesn't have the information, it wasn't trained on that information, etc. But what we can do is inject some context within the prompt itself. So this is what's called a retrieval augmented generation. And how you can do that is you basically get all the documents that describe the information that you want the LLM to know. So for the example that I gave, everything that explains who am I or Karl, and kind of upload it to any kind of data storage. But usually what is used is some kind of a graph. Let me quickly take it up. So yeah, so you use an embeddings model to kind of create embeddings out of these documents, which enables you to easily retrieve information based on the kind of input that the user has, and then inject this information into like the chat message or the prompt itself. So essentially it enables you to build more use case specific solutions using large language models without having to train the model, but just giving it more knowledge base and context about the given situation.
There's a few more questions towards the very top that were just posted, so you can look from Satya and Alu.
Okay, so the first one by Satya: why is Oracle address changed periodically? Trying to understand. It's if we add new functionality. So for example, if we deploy another AI model into the TML, we do also need to update the on-chain Oracle that is communicating with off-chain TML. We need to write a new function to it that let's say we want to add a stable diffusion model. We deploy it within the TML, but also inside the AI Oracle, we now need to add a function that calls out the stable diffusion model off-chain, if that makes sense. And for this reason, we need to periodically, deploy a new Oracle. And if you want to use this new feature, then you also need to change the address within your contract. And the last question by Aliu, can we run prompt that generates visual effect, UI, and the likes? I guess what you're asking is, can the AI generate graphical user interfaces? Yeah, so I don't think the DALL-E model or the image generation models are really that good with generating graphical user interfaces. But what you can do is you can, kind of use the text models or LLMs to maybe give you like an outline or a structure how a graphical user interface would look like, and yeah, use that as a reference. There's another question from Jill: Stable Diffusion Oracle like the Horde project. I don't know what the Horde project is, unfortunately.
And maybe address the final question that is posted by Zaremba in the chat section, as it's a follow-up to the original one.
Sorry. So Zaremba follow-up question regards retrieval augmented generation. The question about convenience of using RAG was quite general, as I haven't used Galadriel yet, but I was thinking, for example, if there are any restriction related to storing, updating the data. So the only restriction I know is that it has to be text-based data. So if you want to use retrieval augmented generation, you cannot provide it with images or video or stuff like that. It has to be basically either PDFs or it can be even like PowerPoint slides. I think it is able to extract the text from them, but essentially any kind of text-based data. In terms of storing and updating, we are using IPFS, so you would need to, if you're updating the data, you would need to generate a new CID or like a new reference to the data endpoint. But yeah, any restrictions? I'm not sure about like limits in terms of the amount that you can store, but I'm sure this information is available in our docs somewhere. I can quickly share the link here as well. And if you have any more questions, you can simply, tag us in the Encode Discord, or even if you join the Galadriel server itself, the developer community is quite, living there. So you can ask the developers from the dev support, and the community can also help you. Oh, and also we have like a showcase channel that you can go and use as inspiration, where a lot of the previous developers have posted what they've built, and you can go and kind of shuffle to what has already been built on Galadriel, and maybe get some inspiration from that.
Perfect. Thank you, Karl. For all of you that, as I said, if you still have any questions or follow-up questions based on the presentation or the slides, which we'll make available tomorrow, feel free to post them on the Discord, and we'll make sure that either Karl or anyone from our team or the Galadriel team will be able to follow up. As a quick reminder, at the end of next week, we will be expecting to receive, your ideas for what you're planning to build, whether that's going to be Galadriel or some of the other sponsors who really want to know. Let us know in short details, a quick overview of like what your idea is, how far along are you with development, and we'll make sure to help you and connect you with people needed to help you with the development over the next 2 weeks. So again, enjoy the workshops this week and next, and towards the end of next week, we'll be expecting you to fill out that form. As for the recordings, as always, they will be published in the Hacker Pack. We usually do this in 24 hours after the event, so by tomorrow morning or the next, you will be having a recording of today's workshop or today's workshops in the Hacker Pack. That is all from me. Thank you all for being around. Karl, any closing words from your end?
Yeah, I wish all the hackers good luck, and let's build the future. We strongly believe that intersection of Web3 and AI is kind of the next thing, or we can all collectively here kind of peek behind the curve and have our impact. So I wish you all very much luck, and be creative, and yeah.
Absolutely. Thank you, Karl. Thank you all once again for being here, and have an amazing rest of your day. See you all.